All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is solving equations by completing the square. What is completing the square? Well, completing the square is another magic formula that you have to remember. So, completing the square only works when you have no number, aka a 1, in front of the square term. We don't have any excuse me. We don't have any visible number in front of the square term. So there's a 1 there. If you don't see a number, it's like a 1. It's like ones are ninjas. If you don't see a number, there's actually a 1 there. So what we got to do is we got to use the formula. All right, so what's the formula? The formula is you go b over 2 squared equals c. That's the formula. Actually, you know what? Let me back up. I'm going to back up. Let me just give you the steps to this. Let's run through the steps. That way you have a repeatable process for these. Okay? So, step 1. You want to actually get the number over. Normally you do want everything equal to 0 when you're factoring, but when you're completing the square is a special kind of factoring. You actually don't want it equal to 0. You want it equal to whatever the number is. So you want the letters left and the numbers right. Meaning, wherever the letters are, for number 1, a squared and 2a, those have letters. If they don't have letters in them, then you move it to the right. So we can't move the 2 and 2a to the right. I'm talking about just the numbers that are by themselves. Those are called constants. The 2 is actually called a coefficient because it's multiplied by the a. But hey, technicalities, right? So just remember, if it has a letter in it, put it on the left. If it doesn't have a letter in it, put it on the right. So we need to do this. We need to add 3 to both sides. All right, step 1. Okay, step 1 done. Not bad, right? Just got to move that thing over. If it's already moved over, then hey, you don't even have to do number 1. Number 2 is actually when we get into doing the thing. And actually, there's going to be another step later on that I'm going to have to add in. So I'm actually going to leave some space here and skip to step 3 because I'm gonna show you. There's going to be a step 2, and actually probably a step 2 and a step 3. Really, I might need to even leave some more space and go to step 4 because later on it's going to get a little bit harder. And we'll come back and I'll show you how to add in those extra steps. But for right now, it's not crazy. So we're going to skip to step 4. Step 4 is when you use the completing the square formula. I'm going to just call it the completing the square, CTS. The CTS formula. Right? That says formula. That's really sloppy cursive there. So we're going to use the completing the square formula, which is b over 2 quantity squared equals c. Okay, so now, and actually you could start on step 4 sometimes. If the number's already on the right-hand side, they didn't start us out that way. But if there was already a number on the right and there was no visible number in front of the square term, then you could just skip all the way to step 4. But we're going to do step 4 now. B is 2. B is the number in front of the letter without the power. Right? So in a standard equation, there's some exceptions to this, but for the most part, when you're looking at these problems, the letter that doesn't have the power, that's the letter that has the number in front of it, and that number is B. If you don't see a number, it's 1. Right? Remember, if there's no number, it's 1. Not 0, 1. If you don't see a number, it's a 1. So B is 2. I'm going to write this off to the side over here. B is 2 over 2 squared. 2 over 2 is 1. 1 squared is 1. Okay, so we found out what c is. Basically, we're trying to figure out what c is. So then we add c to both sides. Add c. And actually, you know what? This is going to be this. Actually, let's do this because I'm thinking like what we're going to have here later on. I'm trying to make spaces for it. 3. Let's make that step 5. And I might even have to move that down a little bit, but this is actually step 5. I was thinking the extra step was going to go before step 3, but it's going to go after step 3. So, okay, so we are going to add 1 to both sides. Add c, whatever c is, right? Because number 1, it's a 1, but it's not always going to be 1. Add c to both sides. Add c to both sides. Okay, so we added to both sides. A squared plus 2a plus 1 equals 3. So then there's 2 things you can do at this point. You can either just do like a plus b over 2 squared, or you could just like, use standard factoring. Standard factoring. And sometimes I'll do cursive, not to be super fancy, because I don't really care about being fancy. If I cared about being fancy, I would use all the fancy math words. It's just like the pen strokes. Like if you do cursive, it's 1 pen stroke, and so there's like less chance of things getting glitchy. So that's actually why I do the cursive. But hey, if you're not super familiar with cursive, it's a chance to be able to start reading cursive. So there you go, 2 birds, 1 stone. You're welcome. But yeah, so number 6, standard factoring. You could do that. I could say, oh, well, what times what is 1 and adds to 2. 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. That would be the standard factoring method. Or you can do a plus b over 2. B over 2 is 1. Right? So obviously, that one and this one right here are the same ones, but they won't always be. Right? Most of the time, they're not going to be the same. So that's what you would factor to. A plus b over 1, b over 2, which is 1. Okay? And at that point, we're done with the factoring part. Now we just solve it. So we solve using, sorry, that's really sloppy cursive there. Solve using, okay, so you're familiar with PEMDAS, probably at this point, right? PEMDAS, please excuse my dear Aunt Sally, because she farted. And then you might have heard of GEMDAS. G just stands for grouping. It's like a big boy parentheses. Like parentheses is really basic, but there's other ways to group numbers besides just using a parentheses. So I prefer GEMDAS. Segue to, okay, if you take that and you spell it backwards, what does it spell? It spells sad meg. Or if you really, really prefer the P in parentheses, like PEMDAS, then backwards it would be SADMEP. SADMEP. Okay, kind of hard to say, but it's maybe kind of fun to say. So if you prefer SADMEP, SADMEG, whichever one you prefer, SADMEP sounds like a character in a Dr. Seuss book. I like SADMEG because Meg is short for Megalodon. Or maybe you know somebody named Meg and you can imagine them sad. Whatever helps you, like whatever word picture helps you. If you can imagine like a Dr. Seuss character being sad, like a SADMEP, or if you can imagine like a shark being sad, or if you have a friend named Meg and you can imagine them being sad. Whatever word picture helps, because basically if you spell it backwards, when you do PEMDAS or GEMDAS, you're doing simplifying. When you're doing it backwards, you're solving. You solve things normally by following that process. And that's it. That's all the steps, all right? So I know like it says 7, but actually we're only doing 1, 2, 3, 4, 5 of those steps right now. Later on, it will be 7. Right now, it's 5 steps. Right, 5 steps. It does take a while, but it is only 5 as opposed to more later, which we'll see in a second. But what we're going to do is we're going to solve using sad megalodon. There's nothing I can do inside the parentheses yet because groupings or parentheses is last. It's last. We're going to do that last. So we get rid of the 2 first. We get rid of the 2 first. How do you get rid of a power of 2? You do a root of 2. A root of 2 is the opposite of a power of 2. So a plus 1, if I take the square root of both sides, it cancels. If I take the square root of 3, I actually have plus or minus the square root of 3. And then now that I've opened up the grouping, I have a whole nother sad megalodon, a whole nother sad shark inside. Just like with PEMDAS. Inside the parentheses, there's a whole nother PEMDAS you got to look for. So I subtract 1. And you're probably thinking, oh, that's going to be 2. Or maybe you're thinking, no, I don't. I'm not a kindergartner. Either way, you can't put these numbers together. Square roots are almost like variables. They act a lot like variables. They just don't like regular numbers for whatever reason. They just like to seclude. They like to hide in their little houses, their little Nike checks over here. So they don't like to play with other numbers. So that's it. You would just leave it like that, actually. And that's the answer to number 1. I am going to start going a little bit faster as we go here. Chop chop, right? And get going. So now that we've got all the steps down, I'm going to start going a little bit faster as we go. And then, of course, pause to add the new steps when we get to that part where we need to add the new steps. But for right now, let's just go ahead and follow the steps. Step 1, letters on the left, numbers on the right. Okay, well, we need to add 8 to both sides then. All right, step 1, done. Step 3, we use the completing the square formula. Okay, I'm going to do that up here at the top maybe because I might run out of space. So b is negative 2. You have to include the sign. Squared. Negative 1 squared is 1. So c is 1 again. We're going to then add c to both sides. Step 5, add c to both sides. Add 1 to both sides. 8 plus 1 is 9. Right. Oh, you know what I didn't do that I forgot to do on number 1 is I forgot to add 1 to both sides. I just realized that. Plus 1 plus 1. Oh my gosh. And if you left me a comment before getting to number 2 and you just pieced out. But hey, if you left the comment, then it's all press is good press, they say. But yeah, so actually that would have been the square root of 4, which would have worked out a lot nicer. So actually, let's go back here. Oh gosh, that's so funny. I can't believe I did that. So, oh, I'm getting rid of the 1 here. Hold on, I'm all messed up. Let's get rid of this right here. So that is 1. This is going to be the square root of 4 plus or minus the square root of 4. And actually, we have more work to do if the square root simplifies. We have less work to do if the square root does not simplify. If it does simplify, plus or minus 2 minus 1. Well, that has 2 answers. 2 minus 1 is 1. Right? So 2 minus 1 is 1. Negative 2 minus 1 is negative 3. So we have 2 answers there, actually. So number 1 had 2 answers. Not well. I mean, it already had 2 answers, but now it definitely has 2 answers. Like 2 separate things I got to write out. So, anyways, we add 1 to both sides. Okay, then we're gonna do completing the square. B over 2 is negative 1 this time. So it's a minus 1 squared equals 9. Square root. A minus 1 is equal to plus or minus 3. All right, went a little fast there. Square root of 9 is 3. But every time you take the square root of both sides, you get plus or minus 3. Right? So now we add 1 to both sides. And I'm running out of space here, but 3 plus 1, we're going to add 1 to both sides, right? So positive 3 plus 1 is 4. Negative 3 plus 1 is negative 2. Right, so we're going to squeeze that in there. So I want to leave some space over here. And let's start changing colors a little bit. I love blue, and I think most people like blue, but not everybody. That's like their favorite thing ever. So let's see. P squared plus 16p equals 22. Okay, step 1. Step 3, use the completing the square formula, b over 2. I'm going to do part of this in my head. We have a little bit of space here. Let's do, let's put a little dividing line right here. So b over 2, 16 over 2 is 8. I'm going to leave the b over 2 part because we need b over 2 for later. So, no, for right now, for later. 8 squared is 64. So we're going to add 64 to both sides. Okay, plus 64 is equal to, what's 64 plus 22? It is 86. I was expecting it to be a square number again, but it's not. It's 86. Well, that's fine, because that's going to be less work for us later. So now we do p plus b over 2 squared equal to 86. And we take the square root of both sides. P plus 8 equal to plus or minus the square root of 86. This is the part where you're like, oh, hey, what is the square root of 86? Well, I don't know. um, I know it divides by 2, but if you divide it by 2, you'd get 43, and I think 43 is prime. So that's not going to simplify. But actually, that means it's less work. So it's actually better if your square root doesn't simplify, because that's less work. So then all we have to do is we just have to say p is equal to plus or minus the square root of 86. And we have to subtract 8 from both sides. And you would literally just leave it like that. So look at that. Even though it's ugly. Sorry, it's ugly. You ugly. P equals plus or minus square root of 86 minus 8. That's actually it. It's an ugly answer. But hey, less math. So I count that as a win. So all right, moving on to number 4. We're gonna chop here. K squared plus 8k. Get to subtract 12 from both sides. All right, step 1 done. Step 3, completing the square. B over 2. 8 over 2 is 4. 4 squared. All right, so 4 squared, 16. We're gonna add 16 to both sides. Plus 16. If I add 16 to negative 12, I get 4. Then I do k plus 4 squared equals 4. Square root of both sides. The square root of 4 is 2, so I get plus or minus 2. Okay, so I'm going to have to subtract 4 from both sides. So this is going to be 2 minus 4 is negative 2. Then if I subtract 4 from negative 2, so negative 2, right, plus or minus 2, negative 2 minus 4 is negative 6. Okie dokie. That's it for that one. And let's switch colors again, because why not? All right, we're moving along here, solving them a little bit faster as we go. We get 33. Okay, so that was step 1. Step 2, we use completing the square formula. 2 over 2 is 1. 1 squared is 1. So I'm going to add 1 to both sides. So plus 2r plus 1 equals 34. Then I do r plus 1 squared equals 34. Square root, square root. The square root of 34 isn't going to simplify because that's like 2 times 17, and 17 is prime. And of course 2 is prime as well. So that's going to be less work though, so hey, that's fine by me. And then the other thing too is let's go ahead and we can subtract 1 from both sides too. So plus or minus the square root of 34. Minus 1. We'd have to minus 1 on both sides next. And there we go. All right. So here we go. I'm going to count off the steps that I'm doing here instead of saying what I'm doing. That was step 1. Oh, and then that's step 2. or step 3. Step 4. Step 5. Oh, sorry. Step 5 was right here. Oh yeah, because there was no step 4. Okay, so step 4 was step 5. Step 6 is what I just did. And then that's part of step 7. And the next part of step 7, we would do 7 plus 1 is 8. Negative 7 plus 1 be negative 6. And that's the rest of step 7. All right, so I went a little out of order there, but those were the steps. All right, so that time I just did the steps. Okay, we're almost getting to where we're about to get some more difficult stuff, but not quite yet. So we're gonna blast through the rest of these here. 26, and that's 636. So 36, 36. That's 10, and then it'd be m minus 6. And then add 6 to both sides. You have plus or minus the square root of 10 plus 6. Okay, so here we've got, and then 6, 36, so we'd add 36 again. 36 from negative 20 would be 16. Square root, square root. Square root of 16 is 4. And we have plus or minus 4. And that's a plus 6, so I'm going to have to subtract 6 from both sides. So I'm doing a couple steps at once here, but we want to start getting comfortable doing multiple steps at once if we're crunched for time. If you're not crunched for time, I would definitely recommend doing it step by step if you have enough time on the test. If you don't, if you're a little rushed and you're not able to get any extra time, or if you just keep practicing and practicing and practicing, this is what you eventually want to get to. Right? So square root of 16 is 4. 4 minus 6. And then, of course, there's negative 4. Plus or minus. So negative 4. Excuse me. It was like a double hiccup. Negative 4 minus 6 is negative 10. Okay. On to the next one. So then we have k squared minus 8k, 48. 8, 4, 16. 16 and 48. 5, 6, 64. Yeah, because those are both multiples of 4. Yeah, yeah. Okay, that's gonna work out pretty interestingly. So then we have k minus 4. Right? And then we square root, square root. K minus 4, we got plus or minus 8. Right, so we'd add 4 to both sides. 8 plus 4 is 12. Negative 8 plus 4 is negative 4. Right, and that's it for that one. Okay, number 10. We add 63. Step 1. We need to figure out what C is. 2 over 2 is 1. 1 squared is 1. Add 1 to both sides. That was step 3 and step 5, I believe. Then we do the variable plus b over 2. And then we do solving. So that was step 6. Now we're about to do step 7. Step 7, we're solving. Right? So then you just get p plus 1 equal to plus or minus 8. P is equal to 8 minus 1 is 7. Negative 8 minus 1 is negative 9. All right, there we go. So switch to yellow here. This time there's numbers on both sides, so it's a little bit harder, but not by a whole lot. Squared plus 2m. Still want to do the same thing. We want to add 48 to both sides. So now, if we add 48 to both sides, it'd be 48 plus negative 6, aka 48 minus 6, which is 42. 42 being the answer to life, the universe, and everything. B squared over, or b over 2 squared is 1. Then we factor. Square root, square root. And we can go ahead and subtract 1 from both sides, actually, because the square root of 43 is nothing. I'm pretty sure that's like a prime number. Minus 1. And that's actually it. Remember, it's actually nice if there's not a square root, because it means there's less work. You just want to make sure there isn't a square root or it doesn't simplify. But if it doesn't, hey, less work. So there you go. P squared minus 8p. Subtract 21. So we're subtracting, and we get negative 15. Then we, half is negative 4 squared is 16, so we add 16. 16 minus 15 is 1. Oh, I forgot to add it on both sides. Lo siento. So we add 16 to both sides, and then we get 1 there. Okay, so then p minus 4 equals 1. Now we're on step 7. So we get p minus 4 equal to plus or minus 1. 1 plus 4 is 5. Negative 1 plus 4 is 3. And there we go with that one. So with number 13 here, we've got, we're going to change to like a gold color here and do m squared plus 10m plus 14, except we need to subtract 14 on both sides. So we're going to subtract 14 on both sides. We get negative 21. And then we want to do our completing the square formula. So m squared plus 10m. That's 5, so 25. 25 minus 21 is 4. M plus 5 squared equals 4. Square root. And m plus 5 is equal to plus or minus 2. 2 minus 5 is negative 3. Negative 2 minus 5, negative 7. All right, there's our two answers. All right, number 14. It looks like a throwback here. They're pretty small numbers. This is nice. And also, remember what I was saying? If the number's already on the right hand side, you can skip number 1 and go straight to number 4. Or was that number 3? Letters on the left, numbers on the right. Every single question so far, there's been at least one number on the left. So we can just skip straight to step 3. It's already in the right form it needs to be in. So step 3, completing the square. Negative 2 over 2 is negative 1 squared is 1. So add 1 to both sides. V minus 1. Square root. V minus 1 is equal to, square root of 4 is 2, so plus or minus 2. We're going to add 1 to both sides, so 2 plus 1 is 3. Negative 2 plus 1 is negative 1. All right. Now we're moving on to the harder stuff. This is a little harder. We're going to have to do it a little differently. And let me show you what that looks like. I'm going to switch colors completely, actually. Let's switch to like a nice purple color. I'll probably just stick with purple for the rest because I don't want to be playing around with colors. This is serious, guys. We're getting serious here. So here's how we have to do this. So we still want to do step 1. Remember, I said step 1 was going to be the same. 5v squared. We want to get the letters on the left. And this time the letter, one of the things with letters in it is on the right. So we need to subtract 10v from both sides. Right? Opposite operations. You want to subtract 10v from both sides. And we want to add 21 to both sides. Right? So step 1, so far we haven't had to put any letters on the left. All the letters were already on the left. But you do need to have all the letters on the left, and if they're not, then you put them there. right? So step 1, letters left, numbers right. So we're still doing step 1. It just looks a little bit different this time because there were some letters on the right. So anyways, we're here. Now I'm going to introduce to you step 2. Here's step 2. Let me insert step 2 here. So step 2, we want to factor out A. We want to factor out A. Okay, so what's A? Well, A is the number in front of the square term. B is the number in front of the not square term. And C is the number by itself, right? A, B, C. Ax squared plus bx plus c. Quadratic formula stuff. So A is 5. We want to factor out 5. So it just happens that 5 does factor out pretty nicely here. If I factor out 5, factoring is dividing. You're just factoring out 5. You could factor out 5v. That would be the GCF, the greatest common factor. But you don't want to do that. You just want to factor out A. Right? And exactly A. Even if it doesn't go into the other number, you still want to factor out exactly A. So I mean, like, literally follow step 2 exactly how I said it. Just factor out A. If I divide 10 by 5, I get 2. And now I'm here. Okay? So I took out 5, factored out 5. I divided by 5. So that's why v squared is by itself. 5 over 5 is 1. So it's 1v squared. And then negative 10, or minus 10, divided by 5 is minus 2, or negative 2. Okay, that was the step 2. That's the step 2. Now we move on to step 3. All right, so step 3, we're going to use completing the square formula, b over 2 squared equals c. But now b is no longer 10. b is actually 2. It's actually 2. But we want to be careful. That's why I left a space. So b over 2. Okay, so 1. So we're going to add 1. But here's what we want to figure out. Here's why there's another space here. Is we need to figure out what to add to the right. So we need to figure out what we're actually adding. So find out the other c, basically. So redistribute c. Distribute c. In order to figure out what to add to both sides. So what I mean is, if we're going to do this, right, there's c, then what do I add to both sides? Well, I'm adding 1 to the left, but actually I'm not. I'm adding 1 inside the parentheses. So what I'm actually adding to both sides is 5. If I distribute, or I should say distribute A, actually. I should say distribute A. What I'm actually doing here then is I'm distributing A. Well, then that is what I add to both sides, really. So I'm going to add 5 to both sides. Then we move on with the rest of it like normal. So actually, let me go ahead and subtract this so I don't have to have too many extra steps here. 5 plus 21 is 26. So I'm actually going to have 26 there, which is pretty nice because 26 doesn't have a square root and it doesn't simplify. So we can move on with our lives here. Number 5 we just did. So we're just doing steps 6 and 7 now. All right, so we factor using the completing the square factor. We factor and then we solve. All right, that's all we have left to do. We factor e minus 1 squared, and then we solve. All right, well, if we're going to solve, let's leave some space for ourselves here. Then we would actually divide by 5 first. Every single time we've been taking the square root first, because there was nothing else to do before we get to the what's inside the parentheses. But now there is. You add or subtract first to both sides. Then you divide or multiply next. So we divide by 5. Then we square root both sides. Then we add 1. All right, that was a really weird answer. Yeah, that's a really weird answer. Let me look at that. Let me know if I messed that one up too, just like I messed up number 1. Let's see what they have here. Okay, so they put it in the calculator and they rounded it. I don't like to do that because it's more work. And doing it this way, like, it looks kind of sloppy, but it's actually in perfect form. Like, it's actually a perfectly acceptable way to write it. It just kind of looks ugly, but actually that's like fully simplified without plugging it in to the calculator. So what we did was fine. Okay, this is already in good form. Step 1 done. Letters on the left, numbers on the right. So we move straight into step 2. Factor out the 4. Right, factor out only the a. Completing the square formula. 4 over 2 is 2. 2 squared is 4. So we'd add 4. But we would not add 4 to both sides because we added 4 inside the parentheses. But if I was to distribute a again, it would have been 16. Right? So for that step 4, when I say distribute a, I'm not saying like actually distribute a, just kind of like in your head, picture what it would look like to distribute a in order to know what to add to both sides. So I didn't know how to put that in words, but you're listening to me say it now. So you're just trying to figure out what to add to the right-hand side. We're going to add 16. 64 plus 16 is 80. Okay, so then we do this. E plus 2. And then we start to solve. Right, so that was step 6 I just did. Now we're going to do step 7. V plus 2 squared. Going to divide both sides by 4. 80 divided by 4 is 20. And then we do a square root. So v plus 2 equals plus or minus square root of 20, which actually does simplify. This is the first time we've had to simplify a radical. In order to simplify, check out all my other videos on this. But basically what I like to do is I like to just get straight to it. What square number comes out of 20? Well, the first square number besides 0 and 1 is 4. And it divides by 4. So square root of 4 is 2. So it's 2 root 5. Okay, if you want more practice on that, check out the other video that I have on doing that specifically. So there we go. Okay, whew, that was just 2 problems. We only have a few more though. Looks like we have 6, nope, 8 more. But the last, well, some of them don't have numbers in front of the squares, so they won't be as crazy. And actually, hold up, because number 17 is tricky because you can actually divide out something. Here's a step 0 that I forgot to mention. Step 0, you want to divide out any GCFs. Or I should say just the GCF, because there's only going to be, one GCF, because it's the greatest. It is the greatest. Divide out a GCF. This almost never happens, but it's literally happening right now. They're trying to punk us. Because check this out. Number 17, everything divides by 7. You might not have caught that, but it does. Everything divides by 7. If I divide everything by 7, I get b squared minus 2b. 56 over 7 is 8. All right, yeah, all right, is equal to 0. 0 over anything is 0. That makes our life quite a bit easier, doesn't it? Because now we don't have to deal with all of the stuff we just had to deal with on number 15 and 16. We couldn't do that on 15 and 16, though, because not everything in number 15 divided by 5. Not everything on number 16 divided by 2 or 4. But on number 17, everything divides by 7. So makes our lives a little easier. So now we go on with step 1. And we skip to step 3 because we don't need to do step 2 now. All right, so if you do step 0, you don't have to do steps 2 or 4. If you forget to do step 0, you'll have to do an extra 2 steps. So not the end of the world. It's really just one extra step if you forget. But if you do that step, it makes your life a lot easier because those are 2 really hard steps. So I would highly suggest looking for that. It's going to happen on number 18 too, spoiler. So then minus 2b plus 1 is 9. Make a little box here to do the rest of number 17. So then b minus 1 squared equals 9. Square root. B minus 1 equals square root of 9 is 3. Remember, it's always plus or minus. And then we add 1 to both sides. Okay, so 3 plus 1 is 4. Negative 3 plus 1 is negative 2. There we go. Box inside of a box. Boxception. Number 18, step 0. We can divide everything by 2. N squared plus 6n plus 5. And we add, subtract 5 to both sides. 6 over 2 is 3. 3 squared is 9. Add 9 to both sides. So then we do n plus 3 squared equal to 4. Square root. So then n plus 3. Square root of 4 is 2, plus or minus 2. So 2 minus 3 is negative 1. Negative 2 minus 3 is negative 5. All right, that was it for 17 and 18. All right, we're almost there. 19, we don't have a thing in front of the n squared again, so that's pretty nice. Sorry, my nose is itchy. Okay, so we subtract 22 on both sides. Subtract 22, let's see, what would that be? 14, 15? So then we, oh my gosh. Ooh, this one's actually really rough because 13 doesn't divide by 2. Ooh, gross. Okay, so if you have to do this by hand, I would recommend going with fractions. If you're using a calculator, you can just go with decimals, right? That would be what I would say. It's going to be easier by hand to do with fractions. It's going to be easier in a calculator to turn it into a decimal. Okay, so I'm going to do it by hand. I'm going to do it the fraction way. If you're using a calculator, it'll be easier. I'm going to show you the by hand way because that's the harder way. But of course, if you're using a calculator, probably better to keep it in terms of fractions. But b over 2 squared. Well, 13 doesn't divide by 2, so we would just square it. 13 squared is 169. 2 squared is 4. So that's C. 169 over 4. We have to add that to both sides. Gross. And if we're going to add that to 15, we have to change 15 as well. 15 over 1 would be 60 over 4, and it's a negative. So that put together would be 109 over 4. Then we do n plus 13 over 2 squared. Square root both sides. And take this plus or minus. Oof, this one's rough. Man, if your teacher gave this to you, I'm sorry. This is crazy. 13 over 2 would be the same thing as 26 over 4. I'm going to subtract that on both sides. Oh, you know what? But actually, it's going to be better if I don't, because here's the answer. We're just going to skip straight to the answer here. Yeah, plus or minus the square root of 109. Because the square root of 4 is 2. So it has a denominator of 2. Then I would subtract 13 halves on both sides, so that would be the final answer, actually. So I don't want to explain that as much because this is just really gnarly. Hopefully your teacher will do more work on this. But yeah, that one was gnarly. I just don't have enough space to really like lay all of that out, and this is already getting to be a long video here. So, moving on. Another crazy one with the fractions here. I'm gonna take out the 5. Oh, I need to add 68 to both sides first, of course. But plus 19 over 5 in. And if I add 68 to both sides, it would be 66. So then I want to, oh my gosh, this one is terrible also. 19 over 5 over 2 would be 19 over 20 squared. 20, 18, 361. Oh my gosh, I'm going to use a calculator. This is getting crazy, y'all. Crazy! Yeah, 361. Okay. For some reason, I thought 19 squared was not 361. I had that memorized wrong or something. So that's why I wanted to check that. So I did get 361 in my head, but I just wanted to make sure. Okay. So 361 squared 19 over 5 in 361 over and then that would have been half of that, which would be 10 squared is 100. Yikes. And then that times 5. 5 over 100 is 1 over 20. So that would be 361 over 20 that I would add to both sides, actually. Plus 66 over 1. And then 66 times 20. Oh, goodness gracious. 66. 6 times 2. Yeah. Times 20. Wow, this is crazy. Okay. So then 5. If you have to do this by hand, your teacher does not like you. They just don't like you. Oh, I need to factor that. Gotta factor it. Gotta factor it. Gotta factor them all. Not 20. We want 10. I don't know why I'm thinking 20. Squared. Okay. And then we add these guys together. So that's a 1, 8, 6, 1 over 20. This is so crazy. And then we solve. Now we're finally on step 7. So we would divide both sides by 5. Or multiply both by 1/5. So we have n squared plus 19 over 10. And that's actually not n squared, that's just n. We would divide by 5, aka multiply by 1/5, so that's 1681 over 100. And then square root, square root. What is the square root of 1681? I feel like that has a square root. But I don't remember that one. Hold on. Let's see. Square root of 1681. 41. Oh my gosh. I felt like it did have a square root. Okay. So, wow, this problem is insane. N plus 19 over 10. So we're going to take the square root, right? Equals plus or minus 41 tenths. Because you take the square root of that whole number. Wow, this problem is just nuts. Then we subtract 19 tenths from both sides. Oh my goodness gracious. Okay. So 41 tenths minus 19 tenths. I just can't math anymore. I feel like my brain is melting. 41 minus, doing 41 minus 19 in a calculator right now. That's how like brain dead I am from this problem. For tenths, which is 11 fifths. There's one of our answers. The other answer would be negative 41 tenths minus 19 tenths, which is 60 tenths, which is negative 6. Wow. Number 20, that is one of the hardest problems that I've ever solved in Algebra 1, if not the hardest Algebra 1 problem. I have to say Algebra 1 because, you know, I do tutor everything from Algebra 1 to Calculus 3. If you need help with any of those subjects, actually, if you're not in Algebra 1, I don't know why you're watching this. Maybe you're in Algebra 2 and your teacher is recapping or something. Um, but if you need help in any subject, let me know. I have all of my stuff in the description below, contact information, all that kind of stuff, as well as a free guide, some free resources, a link to my website. You can go there. You can grab some free resources if you want some extra free resources that are not YouTube videos, um, and some things that are just like links to those or whatever. Go check those out, right? Um, but wow, that's a crazy problem. Okay, here we go. So this is r squared minus 9r. We'd add 38, so 38 minus 9. I can't math anymore. I'm so brain dead right now. That problem like sucked my life out over there. What is going on? All right, so then blinking. Number 20 was insane. That was an insane problem to do by hand. I didn't even do it all by hand. Okay, we want to do completing the square. Um, so minus 9r. 9 over 2 is 9 over 2. 81 fourths. So we'd add 81 fourths to both sides. You know what I'm going to do? I'm going to whip out my Casio. Because it does fractions really well. Because I'm done. I'm done. Let's see. So 81 fourths. Plus 29 is 197 over 4. I'm going to leave it in fraction form, just because I like fractions better, I guess. 197 over 4. Okay. Then you have r minus 9 halves squared. Square root, square root. We're on step 7 already. And take the squared. I don't think 197 has a square root. 196 does, not 197. So r minus 9 halves is equal to the square root of that plus or minus square root of 197 over 2, because I can take the square root of 4. Square root of 4 is 2. And then I just add those up. Since I can't take the square root of 197, and I don't think the 197 simplifies, that might be a prime number, actually. We would just add 9 halves to both sides. So basically like 9 halves, add that to both sides, well, plus or minus the 197, and we are good to go. Whew, okay. On this one, let's see. Yeah, it looks like we're gonna have to do the whole gambit here. So we're gonna besides sub 0. All right, so minus 36 minus 32. Then we factor out the 3. Then we would take half, which would be 10 thirds, and then square that. So 10 thirds squared would be, actually, let me write this number first. 10 thirds squared is 100 ninths. 3 times that would be 100 thirds. So 100 thirds minus 32, 4 thirds. Okay. Then we factor x plus 10 thirds. Now we solve. So we divide both sides by 3, aka multiply by 1/3. So x minus 10 thirds, 4 ninths. Oh, look at that. That's going to have a square root. X plus 10 thirds plus or minus 2 thirds. And then x is going to equal 2. So we're going to have to subtract 10 thirds. 2 minus 10 is negative 8 thirds. And then negative 2 thirds minus 10 thirds would be negative 12 thirds, which is negative 4. Whew. Okay, we're almost done. Almost done. So then we add 45 to both sides. So 52. 7x plus. we'd have to take half. So 7 halves squared is 49 fourths. We'd have to add that to both sides. 49 fourths plus 52. As a fraction is 257 over 4. Okay, then we do x plus 7 halves squared equal to 257 over 4. I don't think 257 has a square root. We can try. 257. No, no. 257. Yeah, no. Okay, so that doesn't have a square root. So we're basically done at that point because we would just say, okay, well then it would be x equals, we're going to take the square root. So the square root plus or minus square root of 257. Square root of 4 is 2. And then we would subtract 7 halves from both sides, so it looks like that for the answer for that one. Okay, and then last but not least, goodness gracious, this worksheet is crazy. So we get this, n squared plus 19, n plus 19. It'd be, I was about to write 19 halves, that's why I wrote the 19 in a little weird there. 19 halves squared, that's 361 over 4. So 361 over 4 minus 60. 121 over 4. Oh, goodness gracious. That's going to have a square root. N plus 19 halves squared. 21 over 4. Square root. N plus 19 halves is equal to plus or minus 11 halves. And then we can add and subtract. 11 minus 19 is negative 8 halves, which is negative 4. Right, and so this actually belongs to this question. This is normally why I do color coding, but there we go. And then negative 11 halves minus 19, that would be negative 30 halves, which is negative 15. Whew, okay, so that was long. That was a hard worksheet, but you know what? We made it through, and good on you for also making it through. If you want this worksheet, this is also going to go onto my website at some point as well, so you can go check that out, myersmathematics.com. I will see you in another video very soon.